Imagine this. In the next breath you take, a machine the size of a small room somewhere on this planet is about to devour more raw information than every classical supercomputer on Earth could handle if they ran non-stop for longer than the entire history of human civilization. Not in minutes, not in hours, in literal seconds. And it's not science fiction. It's the quantum data explosion that's already beginning to unfold right now in 2026. And almost nobody outside the labs is talking about how it's going to completely shatter what we think AI can do by 2030. If you've ever felt overwhelmed by the sheer flood of data in our world, every click, every sensor reading, every genome sequence, every financial transaction happening simultaneously across the globe, then buckle up, because classical computers are hitting a wall so hard they're about to crack. But quantum computers? They're built for this exact moment. They don't just process data faster, they process it in ways that defy everything we learned about computing in school, and the implications for artificial intelligence, for medicine, for climate modeling, for finance, for literally every industry that runs on massive data sets are nothing short of revolutionary. Let's start at the very beginning so you understand exactly why this is the biggest shift in data processing since the invention of the silicon chip. Classical computers, the ones powering your phone, your laptop, every server farm on the planet, rely on bits. Tiny switches that are either 0 or 1, on or off. That binary simplicity is elegant, but it's also brutally limited when you're dealing with problems that have billions or trillions of possible combinations. To solve something like optimizing a global supply chain or training a massive neural network on petabytes of unstructured data, a classical machine has to check possibilities one after another, or at best in massive parallel batches on thousands of GPUs. It's like trying to find the fastest route through a city by testing every single street individually while traffic keeps changing. Now enter the qubit. A quantum bit isn't stuck in 0 or 1. Thanks to the mind-bending rules of quantum mechanics, a single qubit can be in a superposition, meaning it can represent 0, 1, and every probability in between at the exact same time. Stack 2 qubits together and they don't just double the states. They create 4 possible combinations simultaneously. Add a third and you get 8. By the time you reach just 50 qubits, you're looking at more possible states than there are atoms in the observable universe. That's not hype, that's math. And when those qubits are entangled, linked so that the state of one instantly influences the others no matter how far apart they are, the whole system can explore countless pathways in parallel like nothing classical physics ever allowed. This is the core of the quantum data explosion. Where a classical supercomputer might need to crunch through data points sequentially or in limited batches, a quantum system can evaluate trillions of data relationships at once. Think about training today's largest AI models. They require enormous energy and time because they have to iterate through gradient descent across billions of parameters on terabytes or petabytes of training data. Quantum machine learning algorithms, often called QML, change the game entirely. Techniques like quantum support vector machines or variational quantum classifiers can map data into exponentially higher dimensional spaces that classical computers could never navigate efficiently. The result? Pattern recognition that classical AI struggles with becomes almost instantaneous. Right now, in 2026, we're already seeing the first real sparks of this future. Companies have pushed past the noisy intermediate-scale quantum era and are demonstrating early logical qubits, error-corrected units that stay stable long enough to actually perform useful work. Physical qubits, numbering in the hundreds to over 1,000, are being linked in hybrid systems, where classical computers handle the easy parts and quantum processors tackle the impossibly complex optimization or simulation tasks. Error correction breakthroughs mean that adding more physical qubits no longer just multiplies the noise, it actually reduces overall error rates. Crossing a threshold scientists have chased for decades. Suddenly, quantum machines can run circuits with millions of gates without collapsing into randomness. Picture what that means for data. A single quantum processor can simulate molecular interactions for new drug discovery by modeling electron behaviors that would require classical systems to approximate for years. In climate science, it can process satellite data streams and atmospheric models with variables so intertwined that today's forecasts take days on the world's fastest supercomputers. In finance, risk analysis across global markets involving trillions of interdependent data points currency fluctuations, geopolitical events. Consumer behavior can be run in seconds instead of overnight batches. And for AI itself, quantum-enhanced training loops are already showing speedups of hundreds or even thousands of times on specific optimization problems. By 2030, hybrid quantum classical AI systems will be standard in any serious data center. The educational takeaway here is huge. This isn't just faster computing, it's a fundamentally different way of thinking about data. Classical systems force us to simplify reality into linear steps. Quantum systems let us embrace the true complexity and interconnectedness of the universe. That means I won't just get bigger and more power hungry. It will get smarter in ways we can barely imagine today. Imagine an AI that doesn't guess at the best protein folding for a new medicine, but actually calculates every quantum possibility in parallel and hands you the optimal candidate within minutes. Or an AI that analyzes your personal health data alongside global genomic databases in real time to predict diseases years before symptoms appear. Or logistics AI that reroutes entire global supply chains on the fly as new data floods in from millions of sensors. But let's be honest about the road ahead, because real education means facing the challenges too. Qubits are fragile. They lose coherence in microseconds if not kept at near absolute zero temperatures or protected by perfect isolation. Decoherence, noise from the environment, imperfect gates. These are the enemies. That's why the race right now is toward fault-tolerant systems that use thousands of physical qubits to create a handful of reliable logical ones. Progress in 2026 shows we're getting there faster than most predicted. Roadmaps point to hundreds of logical qubits by the end of the decade, enough to deliver practical quantum advantage in targeted industries. By 2030, we won't have universal quantum computers solving every problem, but we will have specialized quantum accelerators plugged into classical supercomputers that together handle data workloads no one thought possible. The economic and societal shifts will be profound. Entire industries built on classical data processing will need to adapt or risk obsolescence. Data scientists and AI engineers who learn quantum programming frameworks today will be the rock stars of the 2030s. Governments and companies are already pouring billions into building quantum data centers, because whoever controls this technology will control the next era of intelligence. There's also the security angle. The same power that rewrites I can break current encryption, which is why post-quantum cryptography standards are being rolled out urgently. Your personal data, your bank accounts, national secrets, all will need new protections built for a quantum world. Yet the opportunities far outweigh the risks if we approach this intelligently. Quantum data processing will accelerate solutions to humanity's biggest problems. Climate models that finally account for every variable accurately enough to guide real policy. Personalized medicine tailored not just to your genes, but to your unique molecular quantum behaviors. Energy grids optimize so perfectly that renewable sources become truly dominant. Artificial intelligence that discovers new materials for batteries, new catalysts for carbon capture, new algorithms for fusion power, all by sifting through data landscapes too vast for any human team or classical machine. Think about your own life. By 2030, your smartphone or wearable might connect to quantum cloud services that analyze your daily data streams, sleep patterns, heart rate variability, environmental exposures, and give you advice so precise it feels like having a super intelligent doctor in your pocket. Businesses will use quantum AI to predict customer needs before customers even know them. Cities will manage traffic, energy, and emergency response with a level of foresight that seems almost psychic. And the creative possibilities? Artists and musicians using quantum-generated data to explore entirely new dimensions of sound and image that classical algorithms could never dream up. The key educational message I want you to walk away with is this. The quantum data explosion isn't something happening to us. It's something we can shape. Start learning the basics now. You don't need a physics degree. Free simulators and cloud access to real quantum hardware exist today. Experiment with simple quantum circuits. Understand superposition and entanglement not as abstract concepts, but as tools that will define the next decade of innovation. Teach your kids or your team about it, because the companies and individuals who treat this as the data revolution it truly is will thrive, while those who wait will be left scrambling. We stand at the edge of a new computational age where data stops being a burden and becomes pure possibility. Trillions of data points processed not in days or weeks, but in heartbeats. AI rewritten from the ground up to think in quantum terms. Problems that have plagued humanity for generations suddenly solvable because we finally have machines that match the complexity of the universe itself. The quantum data explosion is here. It's accelerating faster than anyone expected in 2026. And by 2030, it will have transformed our world in ways we're only beginning to glimpse. The question isn't whether it will happen. The question is whether you'll be ready to harness it. Start today. Dive into the concepts. Experiment. Prepare. Because the future of data isn't coming. It's exploding right now, and it's going to be the most exciting ride in technological history. The choice is yours. Embrace the qubits, master the data explosion, and help write the next chapter of human progress. Or watch from the sidelines as the world changes forever around you. I know which path I'm on. I hope you'll join me. The quantum future is brighter, faster, and more powerful than we ever imagined. And it all starts with understanding how these incredible machines will process the data that defines our lives. Let's build it together.